Hi, I'm CJ and this is my RC channel. So the assembly continues. I tried a couple of different wiring scenarios. I pulled one of these little metal connectors out of the plastic and checked it, and really, if I took all these plastics off and just slid the metal connectors onto the leads, I'm only gaining maybe 2 millimeters of space at most, and it's just it's not necessary. It seemed better just to keep them. I also thought about shortening the wires, but I don't need to put the battery on top, so it didn't seem worthwhile to go through that effort. And since I may need to add some ballast up front, having this extra wire here didn't seem like it was going to be a problem from a weight savings point of view. So I basically just did one back and forth for each wire, just one Z, and I started back at this end, keeping the receiver, right up against the servo, and then pull the next wire and the next wire and the next wire and just tape them down with several loops each of this very narrow gold nitrile. I think that's what it's called. It's a type of gold electrical tape. It's non-conductive, so you can wrap electronics in it, like receivers, which I've done here. And that way I was able to, these batteries are snap-on. There's a little pin there that they clip onto. They can actually be removed, and that means they can also rotate. So I rotated them to face the connector end of the receiver, taped it all over, and I've got my leads out here, and I may run one or more of them out through the side of the fuselage like that. We'll see. In any event, so now I've got this little assembly here, and I can slide this in. And there we are. And now I can take one of these shorter, fatter batteries, the 300 milliamps, and I'm going to put them in upside down, because as you can see, the one of the aileron servo arms is at this end. So if I put it in right side up, I'm going to have that wire potentially interfering, or it might butt up against it and over torque the servo, or try to rip the servos up off the plate, or split the nose as it pushes the battery forward. All kinds of bad things could happen. So upside down it goes, drops right in. So goes right to the bottom, no problem. Leaves lots of room for some extra ballast if I need to put some lead in. And then all I need to do is run one pair of leads to the battery with a connector. That'll be my on-off switch. Did I say battery? To the receiver, I'm sorry. And I bought a couple packs of these connectors, males and females, a while back, because I have a few batteries that use them, and I've got a couple kits that use them, and I've got a charger that takes them. So it seemed like a good way to go with this kit. I'm basically going to take my two batteries, I'm going to get rid of these connectors, I'm going to put a pair of these on. I'm either just going to splice the wires, or I may actually split the heat sink and wire them on. I might also fray a couple of these wires and merge them in, so the battery has both connector options, so they can be used for other things. Either way, I think it would be fine, because as you can see, there's plenty of room going down the center here, and underneath the lid here, the canopy is not, there's no issues as far as space goes. Everything should work out. I've just got to get my aileron wires in. Also, I've come up with a solution for the ailerons. As far as adjustability, I'm going to take a pair of these old Dubros. I got rid of the screws that come with them, and I found some grub screws in my collection that fit. And so instead of having a big screw off the end here and the extra weight and space of that, I've got a nice little grub screw. And so I'm going to use these on the aileron connectors on the wings, That'll make it easy to take the wing off if and when I need to for transportation. I think a lot of the time I'm just going to leave this kit fully assembled with a meter wingspan. This is something you can toss in the back seat of a small car, not to mention in the back of a hatchback. So I probably won't be taking it apart very much, but this will allow me to make fine adjustments to my connection, so I don't have to worry about you know, doing a lot of sub trim to make a less than accurate pushrod length work, and then the loss of range of motion that would come with that. So this is going to work out quite nicely, and I highly recommend this as a solution if you know of a better connector for doing this type of thing, because remember, this has to be a fixed connection up here. We don't have room for anything else other than a simple Z-bend. A lot of people just do a simple L-bend and back here. I think this is a much better solution than the L-bend. I mean, they're brass, so they're not featherweight, but I mean, we're talking fractions of a gram, so I'm just not that concerned about it. This isn't a competition glider, and it's not so much weight that I'm gonna be, you know, weighing it down in any substantial way. So all I'll need to do is, again, splice these in, and then I can take one of these and just crimp some a standard servo connector, which I have some of, and just, you know, make it the right length, like about like that, to reach back here, plug in, excuse me, and I'm good to go. So things are coming along very nicely. I'm going to start working on my aileron setup next, and I'm going to do some Z-bends in these two wires, and I'm going to temporarily mount the wing up so I can figure out where I'm going to come out of the fuselage. Now, there's something I noticed about this, that there is only the one exit for the pull cords. So both your elevator and your rudder pull cords are going to come out of this hole. I could, you know, cut a small hole in the side and glue in a little piece of Bowden tubing or something. I don't think that's worth doing. I think this is going to work just fine with it's a nice wide aperture. I think it's not going to have any problem sharing two very thin pieces of I'm not sure what this cable is made out of. It looks like metal. Let me go ahead and pull this for a moment. Yeah, it's definitely some type of twisted metal, very thin wire. So it's not going to be any trouble having two of those coming out. Now the horn for the aileron is probably going to drop into that slot, but again, I don't think that's going to have any issue sharing that space. So it's a safe space. Sorry, couldn't resist. Sometimes things just pop out of my mouth. So anyway, I don't think there's much to do as far as the rudder here, because it's not round. It's kind of an oblong or almost rectangular, rounded rectangle shape. We have a little bit of room to work with, so we're definitely going to want to square that up. The tail section is a bolt-on, as is the wing. So those two are probably already lined up for us. I'm going to verify that, of course, and if any changes need to be made, it would probably be just a little wedge back here of some type. But we'll cross that bridge when we get there. So the next step, as I mentioned, is putting the wing on and figuring out, you know, okay, let's just say the ailerons come to here. So then we've got a horn coming off it, and we want that horn to have a certain amount of travel. And so then we're going to make our hole for start here, just say. So that's what I need to figure out next, and that's what you'll need to do, is decide, you know, where you want it. And it's probably better further forward than back, because you know, a small amount of this is, you know, sticking out is not going to have any kind of flex, not like this kind of thing, which I was talking about previously. As long as this has some tube around it somewhere, it's not going to be an issue. So I think I'd rather have more wires sticking out of the fuselage where it can have a little bit of a bend to reach the horn and have some up and down flexibility, because, you know, as the horn moves, we're cutting an arc. So, you know, when a control horn is rotating like that on a hinged surface, you can see that this anchor point has, you know, a low and a high at either end, so it swings an arc. So that means that, you know, we've got a fixed point hole, but this control rod is going to move up and down. So the closer we have it to the horn, the more acute that is and the more stress it is bending. So the more room you give it to flex, the gentler that issue, you know, that is, there's less pressure, and it's going to work better. So that's where we are now. So what I need to do, as I'm getting this is a bunch of things have to kind of be done simultaneously, because this is when this goes in, it's in. I'm not going to be able to, you know, reach in with some type of tool and pull one of these horns off and make some kind of change. Another thing I recommend is, as you're doing this process of putting this together, your board, check your servos periodically. Make sure they're centered. I found one, as I was testing things, I found that I had one of my horns like one notch over out of center. So, you know, double, triple, quadruple check, because once this goes in, it's in. And prying this thing, you know, like if you two-sided taped it down or if you've hot glued it down, this fuselage is so thin, it's an eggshell. You're going to destroy it trying to get this thing out. You're never going to get these servos back out of this thing unless you've crashed it and destroyed it, and or you're getting rid of it. You know what I mean? So make sure you've got everything right. Now, the things that need to be done before this goes in. These cables, I mean, these push rods have to be decided upon. The holes have to be made in the fuselage. The tubing that is going to guide them needs to be installed and trimmed to fit. And then these need to be attached to the horns. And that's going to be a real juggling act there, let me tell you. So then also the two pull cords have to be looped around through the hole and be crimped so that they are fixed, and they need to be run through the tail before this gets glued in or taped in, or you're not going to get, you know, you're going to have a real mess, because you're going to have to try to get this thing out to do the things you didn't do. So don't leave anything out. Don't be in a hurry. This is, I cannot tell you how many times I have taken this thing apart, put it back together, made changes. I tried doing the wires down at one end, or kind of looping them together. This was not my first solution. This is like my second or third, and I thought about or tested for all the other options I had talked about, like pulling the connectors off, things like that. So you may have, if you're not using exactly the same hardware that I am, make sure that, you know, and even if you are, you want to make sure everything works for you. You want to make sure you're happy with it. You know, this little assembly here has come in and out of the fuselage. I can't tell you how many times over the last few hours, as I've just checked, double checked, triple checked, tinkered, fitted, you know, taped, retaped. It's a great kit. It works. I think this is going to be very nice, but you've got to put it together properly, and it's tough. And if you make a mistake, especially when you get to these later stages, you could totally hose it and, you know, have no choice but to order a new fuselage or a new kit. I'm not sure if they sell replacement fuselages for this kit. Some of the manufacturers do sell separate parts, like a replacement wing or a replacement fuse, but those are usually more than half the cost of the kit itself, and then there's the shipping on top of it, so that's not something you want to have happen to you. So let's see, what do I need to tell you now? Oh yeah, I've already bound the receiver. That was one of the things I did before I started into the wiring, because I knew I mentioned in the previous video that I was going to clone the Raven 1500 airplane in my radio, so I would have all of those settings, and that's exactly what I did. And then, to make sure that I had things correct, I sat down with the tray, plugged a battery in to the receiver, and then went through my transmitter configuration, and okay, I know that when this servo moves, let's say I want this to be my elevator servo, then forward is up because I'm pulling, okay? So made sure that was squared away, made sure the rudder was squared away. Okay, if I'm going to have the horn on this side, then pull is in this direction. Okay, good, that's matched up. And then the ailerons, I had to switch the aileron and auxiliary one for the other, because I had them backwards to what I wanted them to do, and then making sure that they're going the right direction, that they're that little dance they're going to do is correct, because I have the ability to make them both move forward and back at the same time with the throttle stick, and then with the aileron stick I get this, and if I do them both I'm getting a mix of the two, and it's fantastic. I really hope that some of you guys that are building this have a 5 or 6 channel receiver, and you try doing that kind of a mix setup where you've got the ability to do a lot of flap or a little flap, to have different flight modes, to have a launch mode, to make use of reflex, to give you speed and to give you a good launch mode and a speed mode, and then some really big flaps so you can do some nice landings. And one of the things with if you're doing competition, or you want to try, or you just want to kind of learn how you would do it, you want to be able to catch the airplane by the wingtip that has the horn on it and chuck it right back up into the air again. And to be able to catch the plane, you want to be able to bring it in close and then snap those flaps all the way down, and have it dramatically slow the plane and kind of balloon up at you, and then just grab it out of the air and chuck it. That way you can get as many repetitive flights within a certain amount of time. So anyway, I'm going to start by pulling this out again. I'm going to attach the wing, and then I'm going to, well, also one of the things I want to do, I want to make sure that my screw for the wing isn't too long and isn't impacting on the receiver. So what I'm going to do is start screwing the wing on, and then back it out and slide the receiver back out and see if it has pushed down on the tape or not. And if it's not pushing down on the tape, great, good. If it is, I may have to shorten one of these wing bolts a little bit, trim some off the edge, because I don't want it crushing the receiver. That would be bad. So that's my my next step. Now, as you can see, they do give us our springs, which is nice. It's a very complete kit. Someone had asked if the yellow strip of fiberglass comes with the kit. It does. That's part of this package. as is this. The only thing that I am adding in here so far, other than tape, and I haven't even used glue yet, the only thing I've added to this other than tape is opting to use these little Dubro connectors for the ailerons. Other than that, every piece of hardware was included in the kit. Of course, the servo arms came with the servos, but everything else, the wire, this little bit of housing, the wing screws, the tail screws, all of it comes in a package with this kit. So it's very complete. The way I am installing stuff has necessitated some slight changes. If I was mounting the servos more rearward, I would not need to do what I'm doing, but that's my choice. You could potentially put the receiver up front, move the servos back an inch so that this servo is mostly underneath the leading edge of the wing here, and then these push rods would work. They are not long enough where I have my forward servos. Now, I could have switched to the rearward servos for my ailerons, but I have discussed several reasons why I don't want to do that. So I want to keep them up front. So, and I didn't have any push rod material this thin. Let me just measure that again, just to give you some exact numbers. Let's see, this is 3/4 of a millimeter, and the thinnest stuff I had was a millimeter even. So what I have will not work with the tubing they provide, so I had to cut some Bowden tubing of my own, which will work just fine. Again, it's just a guide to prevent flex. And I did my Z-bends. I did those using a pair of pliers that is specific for that. It's a Great Plains product. These can be very hard to find. I don't think Great Plains is producing them anymore. I'm not even sure Great Plains exists as a company anymore. So if you are if you like to do a lot of planes, if this is a long-term hobby of yours, I would get my hands on one of these while you can. It's the only way to get a good, tight Z-bend. As far as I've tried needle nose pliers and all kinds of things, and nothing works as well as those Z-bend pliers. They are designed for it. So I have 2 push rods cut now that are long enough for each of the 2 servo locations, and there's going to be some extra on either of those that I can trim later, to just not have too much extra at the end. I'll leave a little hanging out, but not more than a 1/4 inch or so. There's just no need. So I've gotten that taken care of, and having looked at locations for the cable to come through, let's just say that there is a control horn. So our pivot point is going to be about 1/8 of an inch rearward of the beginning of the aileron hinge location there. So I am figuring on having that. I put these 2 pieces of tape here to just kind of mark where I'm going to do the beginning of the holes in the fuselage. And the way I'm going to cut those, I'm going to start by taking a drill bit the size of the Bowden tubing, drilling a straight hole in, and then angling the drill and stretching that hole out. I may use a file a little bit on that as well. I've got a small rat tail file that will help me elongate that hole. And so that's going to give me my hinge point. I figured that from there to there, that's a decent amount of leeway for this push rod to move and flex a little bit with the motion of the horn without causing problems. So I'm going to go with that. I'm also going to drill the hole right on the seam. That is potentially the weakest point where the fuselage was molded together, and so that's probably as good a spot as any to go ahead and make the hole. So the next thing will be cutting a slot in here for the horn, and then the same on the opposite side. The key to doing that correctly is going to be making sure that the distance from the beginning of the hinge location back to where the horn enters is the same on both sides. If it's any different, you're going to have a different amount of leverage, you'll get a different amount of movement. So you want that to be identical on both sides. So measure, mark. A good way to do that is to put a piece of paper tape, like thin masking tape, over the area and make your measurements and your marks on the tape and then cut through the tape. I think an X-Acto knife will work fine. This is a thin fiberglass with foam underneath. Try not to cut through to the opposite side. The idea would be to cut a slot in the top layer and clean out the little bit of foam there and leave, well, in the bottom layer, and it's the top layer now because it's upside down. Leave the bottom layer untouched. Don't cut through all the way through. Lay in some 5-minute epoxy and sink this sucker in, and I may also either put a few notches or drill some really small holes just to provide a little bit of more grip for the glue, because you know, you're only going to be sinking this into the wing maybe a couple of millimeters. It's not very thick back here, and it may not even be, you know, this distance thick at the back end where it's gonna where it sits. So you know, you don't want this thing coming off, so it's got to be done glued in well. I wouldn't use foam glues, I wouldn't use CAs for this. I would definitely use epoxy. And also, before you glue these things in, any enlargement to that hole, and then actually press fitting the end piece for these, the little black cap, do that before you glue it in, because once it's glued in, you don't want to be trying to squeeze that thing on with a pair of pliers and potentially tear this thing back out, or at least weaken the joint. Do as much of things like that as you can before you glue stuff. So so that's what I'm going to do. You've seen the tubing that I've got, so I'm going to measure my outer diameter here and confirm it, and then I will I'll use a metric drill bit of the correct size and drill 2 holes, and then go at it with a file as needed. I may drill more than 1 hole, like drill 2 holes, maybe a 1/2 inch apart, and then use an X-Acto knife or micro saw to cut the space between the 2 holes and connect the tops and bottoms of the 2 holes to create a longer slot. That's another way to go about it. So I will let you know how I actually end up doing it. These little airplane stands are really handy when you're trying to, you know, work with a fuselage when you've got a wing and or tail section attached to it. So I'm going to take the wing off and I'm going to do the holes. I hope you enjoyed this video. Please click like and please subscribe to my channel.